with our first revision class, which I will start from chapter 1. We will go as it goes in the textbook. So it will have initially all your chemistry chapters. If you want like that, or you want different, we can do that also. We'll discuss it later, but let us start with chemical reactions and equations. It is a very important chapter, Mark's distribution. Yet to come, I think, I'll let you know. So this chapter basically is very simple. It has a lot of equations in it, and the best way is to write all the equations every day so that you don't end up messing it up in the examination hall. So what do we study about chemical reactions and equations is, what is a chemical reaction? A chemical reaction is when a reactant basically gets converted into product. On what base is our chemical reaction stored? They are basically written on to satisfy the law of conservation of mass, which says that mass can neither be created nor destroyed, or the total mass of the reactant before the chemical reaction should always be equal to the total mass of the product after the chemical reaction. Okay, so how do we know that a chemical reaction has taken place? The four basic conditions which show that a chemical reaction has taken place is, first, change in state. No need to write, I am writing so that I can quote reactions. Change in state. So for this, what activity do we do? We take a magnesium ribbon, burn it, and when you burn it with the help, holding it with a pair of tongs, you get a white dazzling light, and you get a powder which is nothing but magnesium oxide. So you find that there is change in state. 2 Mg plus O2 gives what? 2 MgO. So this is our first reaction or first condition, that whenever a chemical reaction has taken place, there will be a change in state. Second will be what? Change in temperature. Change in temperature. When I talk about change in temperature, I generally take zinc plus H2SO4. It forms what? ZnSO4 plus H2. This reaction is an exothermic reaction, and the beaker where it is done basically gets warm. So we know there is change in temperature. The same example can be used for evolution of a gas. Okay, what we do in evolution of a gas, if a chemical reaction is taken place and some gas is released, this hydrogen gas can be tested by bringing a burning splinter near the mouth of the test tube, which goes off with a pop sound. Then the last is change in color. For change in color, we generally use an activity where we take what? Lead nitrate. What is the formula of lead nitrate? PbNO3 twice. And I react it with what? Potassium iodide. I get what? A yellow precipitate of PbI2, and I get potassium nitrate. This shows that there is always what? Change in color. This is how you should also read. Whenever I take my first page, I know that what is a chemical reaction? The reactant combined to form a new product. What are the four conditions which show that a chemical reaction has taken place? Change in state, change in temperature, evolution of a gas, and change in color. Change in state, take magnesium ribbon and burn it in the oxygen, or burn it in presence of oxygen. You get a white powdered substance which is called as magnesium oxide. Magnesium burns with a white dazzling flame. Whenever there is a change in a chemical reaction is taking place, there is change in temperature, which can be reaction of a metal with acid to form salt, and it liberates what gas? Hydrogen gas. This hydrogen gas can be tested by bringing a burning splinter near the mouth of the test tube, which goes off with a pop sound. And then there is change in color, which is basically lead nitrate reacting with potassium iodide to form lead iodide and potassium nitrate. Then we know how to write a chemical reaction. Whenever I am writing a chemical reaction, I should write the reactant to the left side and product to the right side. I should always write whether it is an exothermic or an endothermic reaction. And also I should write the state of the reactants. Let us suppose I write C plus O2 gives CO2. So how should I write? C solid plus oxygen gas gives carbon dioxide gas plus heat. This is a standard reaction. If there is a catalyst used and there is a temperature used, I should write it above the arrow. But for your final exam, states are not that great. If you remember right, if you are confused, don't try to lose marks. Okay? Balanced chemical equation. We balance it on the basis of what? Law of conservation of mass. For balancing any equation, let us suppose we use Fe plus H2O gives what? Fe3O4 plus H2. First step, block the reactants or draw the box around what? Reactants. Isn't it? So that we do not change any of these by adding 2, 3, 1 to it. Anything I want to add, I have to add it before. Then what I do? I make a table containing what are the elements present. So I write what are my elements present? Fe, hydrogen and oxygen. Fine? How many Fe's present here? 1. How many hydrogen? 2. How many oxygen? 1. Whichever is most, I will start balancing first that. So both hydrogen are balanced. Then what is not balanced? Oxygen. Oxygen is what? 4 there. Here oxygen is what? 1. So what should I write here? 4. The moment it becomes 4, hydrogen becomes what? 8. So I will immediately go and balance my hydrogen. How should I balance? By writing 4. So now you know that hydrogen is balanced, oxygen is balanced. What is not balanced? Fe. So what I come and write? 3. Then I will again draw a table and check whether the reactant side and product side are same. If they are same, then I will finally write the equation as 3Fe plus 4H2O gives Fe3O4 plus 4H2. And then in the end, I can write the state of these substances. So this is how we balance a chemical reaction. But till date, in board exam, never a reaction has been asked to balance. Because whatever reactions you write are all balanced chemical equations. So till date, I think 20-21 years, never a question has been asked that this is a chemical equation, kindly balance it. They have not asked. They expect you to write what? Balanced chemical equations. So just go through it, learn how to balance, but you can go through once the steps of balancing. Okay? So our first equation, write along in a sheet. Please write along in a sheet. List of equations of chapter 1. List of equations of chapter 1. List of equations of chapter 1. First one, 3Fe plus 4H2O gives Fe3O4 plus 4H2. 3Fe plus 4H2O gives Fe3O4 plus 4H2. Next equation. If I take carbon monoxide and I react it with hydrogen at 340 atmosphere, what is my reaction? Carbon monoxide plus hydrogen. If I react it at 340 atmosphere, I will get what? Methanol. CH3OH. Is right. CO plus how much H2? Balance body? 4. So 2H2. CO plus 2H2 at 340 atmosphere gives what? Methanol. If I have to write its state, carbon monoxide is gas, hydrogen is gas, methanol is liquid. Okay, now the third equation, which is the equation of photosynthesis. What it is? 6CO2 plus 6H2O gives what? C6H12O6. Array. Where have I gone wrong? Main product of photosynthesis is release of oxygen. Array. 6CO2 plus 12H2O gives C6H12O6 plus 6O2 plus 6H2O. Still this equation is wrong. Why? Photosynthesis generally takes place in presence of sunlight. Okay, so I have to write sunlight. Still wrong. Why? It is absorbed by chlorophyll. Still wrong. Why? State. I have written it as liquid, you can write it as aqueous, dissolved in water. This some textbook will write O2 as gas, you can even write this as aqueous because this is also dissolved in water. If you write there oxygen aqueous, you have to make this also as aqueous. Okay. Or you can write all as I taught as gas. Your textbook says it as aqueous, liquid, aqueous, aqueous and liquid. Fine. So this is how our first three equations are. 3Fe plus 4H2O gives Fe3O4 plus 4H2. CO plus 2H2 at 340 atmosphere gives methanol. C6CO2 plus 12H2O gives C6H12O6 plus 6O2 plus 6H2O. This is how we are supposed to write our chemical equations. Textbook Tegeri. First question. Why should magnesium ribbon be cleaned before burning in air? To remove undesired layer of carbonate and oxides. Carbonate and oxide should be fine. Write balanced chemical equation for the following. Hydrogen plus chlorine gives hydrogen chloride. H2Cl2 gives 2HCl. Barium chloride plus aluminium sulfate. Barium chloride BaCl2. Aluminium sulfate Al2SO4 thrice gives what? It is given what? Barium sulfate BaSO4 plus what? AlCl3, aluminium chloride. Now let us start. We have to balance this equation. How many Al? 2Al. So let us start with 2Al. Now how many SO4? 3SO4. So I will write 3BaSO4. So if I make that as 3BaSO4, I should make this also as 3BaCl2. So now 3Ba and 3SO4 balance. But let us see, 3 2s are 6. Here also 3 2s are 6. How many Al? 2Al. So the equation is balanced. So you get 3BaCl2 plus Al2SO4 thrice gives 3BaSO4 plus 2AlCl3. Next, sodium plus water, Na plus H2O. What it will form? NaOH plus what is given? Plus H2. NaOH plus H2. Correct? Balance. How many H2? If you say 2 H2O, oxygen also need to become 2. This also becomes 2. So now see, 2 Na plus 2 H2O. total hydrogen should be 4. ಇಲ್ಲಿ 2 ಇದೆ, ಇಲ್ಲಿ 2 ಇದೆ. So 4. So our balance equation is what? 2Na plus 2H2O gives 2NaOH plus H2. Here, now the next one. Write a balanced chemical equation which states symbols for the following reaction. A solution of barium chloride and sodium sulfate in water. This reaction we have been studying multiple times, even in double decomposition, double displacement reaction, we study the same. What it is? A solution of barium chloride, BaCl2, aqueous plus sodium sulfate, Na2SO4 aqueous forms what? A precipitate of BaSO4 solid plus NaCl. How many NaCl? 2 NaCl. Okay, aqueous NaCl maybe. Next one, sodium hydroxide solution in water reacts with hydrogen chloride solution in water. So what? NaOH aqueous. This you can write even liquid, okay? These two can be liquid also because they are not mentioned in water. So you can write all these as liquid. Now NaOH aqueous plus HCl aqueous is what? NaCl plus H2O. What have they written for NaCl? To produce sodium chloride solution. So this solution is aqueous solution plus H2O liquid. So this is all about the first part of chemical reactions and equations. Tomorrow we will do types of chemical reactions and a little part of carbon compounds. Thank you.